Hello, everybody. Today we are going to be talking about significant figures, should be a new concept for a lot of people. This is the first time that this shows up in science. And when we talk about significant figures, really what we're talking about, we're not talking about important figures, right? It's not significant in the same way that significant comes across in the regular English language. When we talk about significant figures, what we're really talking about are measured numbers, right? Measured figures. Right? And the reason this is important is because that in science, we are trusting the measurements of someone who might be all the way around the world. We might be trusting the measurements of a number of different laboratories from a number of different places around the world. And so we need a set of rules that help us determine where do we measure, how do we measure, where do we estimate, where do we not estimate. Right? So there's two important rules. The first one is that you want to use a piece of measuring equipment for its intended purpose, right? I can't use a meter stick to measure how wide a piece of hair is, right? That is not the right tool for the job. You always want to use the right tool for the job. If I have something really, really heavy, I'm not going to use a triple beam balance and weigh it in pieces. I'm going to find a scale that can handle the amount of weight. If I have something really, really light, I want to find a scale that is made for weighing things that are really, really light. So the first is using the appropriate piece of equipment. And the second important rule is that you can only estimate one decimal place past what an instrument tells you. And what that means, and I'll show you with an example here, is that if I have a ruler, let's say it gets a 12, 12.1, 12.2, 12.3, 12.4, 12.5, 12.6, 12.7, 12.8, 12.9, 13. Right? And then it keeps going. If I have this ruler and I want to measure the length of this funky green square that, goes on, and I want to see how long this thing is. Right, and I have a measurement that comes right about there. That means that my measurement is going to be 12.49. Right, the instrument gives me the tenths place, which means that I know all of this because that's directly from my tool, and I'm allowed to estimate the one place past that, right? The rules of significant figures say that we trust you, the person making the measurement, to be able to estimate one place past whatever the instrument gives you, right? Which in this case is the hundredths place. Now, if I came to you and I said that this measurement, this green thing is 12.498721, nope, that's 9132 centimeters long. This piece of equipment does not give me enough accuracy to get this big of a measurement. Right? I cannot accurately get the millionths place with a ruler that only goes up to the tenths. Right, so that's what we talk about when we're saying we can only estimate one decimal place past. Right, if it gives me the tenths, you can give the hundredths. If it gives you the thousandths, you can guess the 10,000ths. Right, you're allowed to estimate one place past what the instrument tells you. Right, so those are the first two rules for significant figures. The next set of rules for significant figures come from the fact that 0 is a number. Really, the different types of zeros that exist. There are 3 different types of zeros, 3 different places that 0 can be within a number. Right? The zeros can be in the front of the number, right, leading the other non-zero numbers. The zeros can be in the middle of the number, captive, trapped between two non-zero numbers. Or the zeros can be at the end. They can be trailing the other non-zero numbers. And because there's 3 different places zeros can be and a bunch of different roles that zeros can fill, we have different rules for different zeros. Right, the first rule is that leading zeros, zeros that come before any other number, are never counted as significant figures. They're never counted as measured. Right? These zeros are here to show you the scale of your measurement. This is a very small 12. Right? This is 10 hundred thousandths. Or sorry, 12 hundred thousandths. And the only way we can show 12 hundred thousandths numerically is by using these zeros to show the scale of that number. Right? Because that they're there as a scale, right, to show you how big or how small the number is, they are not counted as measured. They are not counted as significant figures. Right? The second, right, are captive zeros. Right? Zeros stuck between two other numbers. Those are always going to be significant figures. There is no way for me to measure the thousands spot and the singles, right, the ones spot, without passing through the tens and the hundreds. Right? There's no way I can get both of these measurements without also knowing that there are 0 hundreds and 0 thousands. They're not there as placeholders. They're not there as estimates. Right? They are exactly 0. Right? There are no tens. There are no hundreds. There's no guessing. There's no estimating. Right? There's just nothing in that spot. Right? Which means that it is a measurement. Right? So it is a significant figure. Our third type of zero are the zeros that show up at the end of a number. Right? Now, these zeros are the trickiest because there's actually 2 different types of trailing zeros. There are trailing zeros without a decimal point, and there are trailing zeros with a decimal point. Right? Trailing zeros without a decimal point are never significant figures. These zeros serve the same purpose as our leading zeros. They're there to show you how big the number is, right? They're there to show you the scale of the number, or they're there as an estimate, right? There are roughly 1,200 students in chemistry this year, right? If one of you drops out of chemistry, that does not mean that there's 1,199 students, right? This is a rough number, right? It's not a perfect measurement, it's an estimate. Right? So there's no decimal point. That means these are there as placeholders, those are there as estimates. Right? Sorry, I saw a question in the chat. In this first one, why aren't the zeros between the decimal and the 1 counted as leading? They are. All of these are leading zeros. All 4 of them. Any zero that comes before a non-zero number is a leading zero. right? So back here are trailing zeros. These zeros here without the decimal point, that tells me that this is an estimate, or that these zeros are here for scale, right? We have 1200, right, roughly. Whereas here on the bottom, with the decimal point, that tells me that I measured there are exactly 1,200 students in chemistry this year. If one of you drops out of chemistry, there will be 1,199. Right? This decimal point tells me that I measured every spot. Right? These are always significant. Right? The presence of the decimal at the end of the number means that the zeros at the end of the number are significant. All right, Jesse asks a fantastic question. What about this number? Right, 1,200.00. These are all significant figures, right? These zeros, all four of them, are trailing zeros. They come at the end of the number, and there is a decimal point. So that means I measured, I have 1,200s, 0 tens, 0 ones, 0 tenths, and 0 hundredths. Right, there are 6 significant figures in this number, right? All of these values are measurements. Right, so we're going to move on and do a couple of practice problems here. Right, first, right, how many significant figures are in this number? Right, you want to look at what kind of zeros are there, and are they measurements or are they placeholders? Right, so are they significant or are they not? I'm going to give you about 10 seconds. Again, if you need more time, please feel free to pause the video and then jump to the answer. Right, so here, if I'm going to look at this number, there are 6 significant figures in this number. Right, there are trailing zeros, right, zeros at the end of the number, and there is a decimal point in this number, which means that these are all measured units. Right, there is exactly, like I said before, 1,700s, 2 tens, 0 ones, 0 tenths, and 0 hundredths. And so all of these were measured. There are 6 measured numbers, 6 significant figures. So question, if I were to define a significant figure, could I say they are numbers that define units of measurement? I don't like the wording that you used there. If I was going to define a significant figure, I would say that it is a number that has definitely been measured, right? A piece of a measurement that is exact, right? Because I could, for example, right, let's look at the other options, right? If I wanted to say there's 3 significant figures, I can do this. Here there's only 3 significant figures, the 1, the 7, and the 2. The 0 here is a trailing 0 without a decimal, means that this is either an estimate or a placeholder, right? But it was not measured, right? So a significant figure is a piece of a measurement that was measured, right? Because this can still be centimeters, but that just means I didn't measure whatever this single spot was, right? I guessed it, or I estimated it, or I didn't have enough information or the right tools for the job. Right here, for 4 significant figures, I can do something like this. Right, the only difference between these two numbers is the presence of the decimal point, but the presence of that decimal point tells me I measured, and there is nothing in the singles spot. Right, there is exactly 1,720 centimeters. I'm not guessing, I'm not rounding, it's exactly that number. And then here with the actual number we have, it's even more precise of a measurement. I measured, the 1,000, the 700, the 20. There's 0 singles, 0 tenths, and 0 hundredths. All of these were measured. Because they were measured, they count as significant figures. All right, let's try another. Right here again, I'm going to give you about 10 seconds, and then don't forget, look at what kind of zeros you have, right? What kind of zeros are there, and are they placeholders? Are they measurements? Are they significant or are they not? For this one, we have two different types of zeros. We have two zeros in the front. We have leading zeros. Right? These zeros are there as placeholders. They are not significant. Right? They're there to show me the scale of the number. We also have two captive zeros, right? Two zeros in between. Right? These zeros are significant, right? There's no way for me to measure this 2 and this 3 without also measuring the numbers that come between. Right, so if I want to define how many significant figures there are in this question, there are a total of 4 significant figures. Right? The 2, the 0, the 0, the 3. Right? Leading zeros never count as significant figures. Right? So that's why it's not 6. The captive zeros do count, which is why it's not 2. Right? Why do you need both the tenths and the hundredths? In the previous question, you don't, right? So if I'm looking back at this number, I don't need these zeros, right? In math, you don't need those zeros. I can just write this. And this is the same thing mathematically. But we're not talking mathematically here. We're talking about a measurement. These two measurements are very, very different. This measurement, 1720, no decimal point, can be any value between 1729 and 1720. Right? I have no idea what this 0 represents. Right? It is rounded. There's no decimal point. So I can be anywhere between 1720 and 1729 centimeters. But the top one, this is exact. This is exactly 1720.00. Right? That means I know that there is exactly nothing in these spots. It is not. I know it's not that. Right? I have no idea what comes after, but I know that these are all pieces of the measurement. I have measured all of those spots and there's nothing there. Right? Maybe a better example of, I'm going to go backwards. Right? Maybe a better example for trailing zeros would be to talk about things like how many people are on the world, right? How many people are here on the planet, right? Right, there are 7 billion people on the face of the earth. Right. Tomorrow, my friend is having a baby. That is not the 7,000,000,001. Right, 7 billion in first person. Right, this is an estimate. Right, these are not measured numbers, right? We know roughly how many people are on the face of the earth. And if we needed a more accurate number, I'm sure there is a more accurate number that probably goes into the millions, right? But there are so many people that are born and die every day that we can't realistically keep track of this section, right? This is an estimate. There is one significant figure. There's only one piece of the measurement, right? But if I look at, I want to buy an apartment, right? Or I want to buy a house, and they say that the price is, no, I'm not going to use 7 again. They say the price is $6.4 million. Right, that's not enough zeros. Right, they say the price is $6.4 million. If I show up with 6399999 I do not have enough to buy that house. Right, this is an exact number. This is exactly what I need. If I showed up with more money, they would give me change. If I show up with less money, they're not going to give me the house. This is an exact measurement. I need exactly this much money. All right, the decimal point is what tells me that it is exact. Right, all of these are significant figures. Right, all of these are part of my measurement. Whereas here, only this is part of my measurement. This is all estimated. Let's jump forward back to where we were before and try another practice problem. Again, take a second, pause if you need more time. So for this question, the answer is 5. We have 5 different significant figures, 5 different measured numbers. These zeros are captive zeros. They are stuck in between. There's no way for me to measure how many thousands there are and how many singles there are without passing through the tens and the hundreds spot. Right? All of these digits are part of my measurement, right? Whether that measurement is dollars or people or centimeters or miles or liters, right? No matter what unit I choose to use here, this is a measurement that has exactly 5 measured digits. Right? Notice, right, there is no decimal point in this number, and that's fine. Right? The decimal point would only be needed to tell the difference between significant figures if there were zeros that came after. Right? These zeros at the end after a non-zero number are only significant if there's a decimal point. Right? Let's try one more. Right here we have 2 different types of zeros. Right, we have a captive zero here, and we have a trailing 0 here. Right, captive zeros are always significant, so this counts as a significant figure. These non-zero numbers count as significant figures. So the only thing we're really questioning is this 0 at the end. This is a trailing 0, and it will only be significant if there is a decimal point at the end of the question, at the end of the measurement, and there is no decimal point at the end of this problem, and so that means the answer here is only 5. Right? Only these 5 are significant. This singles spot is an estimate, or it's a rounding, or it's something we don't have enough data to actually say accurately. Right? If it was 132030 decimal point, it would have 6 significant figures because this 0 would be a piece of the measurement. It would be exactly 0. But without that decimal point, this 0 at the end is a piece that we have either rounded or we don't have enough data to accurately say. So only the first, or these 5 digits are significant digits. All right, last practice problem here. How many significant figures are in this number? If I take a look at this number, I see that there are a lot of digits here, right? But all of these are trailing zeros. Trailing zeros are only significant, they only count as part of the measurement if there is a decimal point here. And there is not a decimal point here. Right? Which means that the correct answer to this question is 3. There are 3 significant digits here, the 1, the 3, and the 2. These zeros are all placeholders. They're all there to show you that this is a ginormous number. Right? When we talk about how many ants are there in the world, right? It's a ginormous number. There's lots of ants. Right? But we can't count them all. We don't have an exact number for them, but we have an estimate. Right? These zeros are trailing zeros that are not significant. They are not part of our measurement because there is no decimal. If there was a decimal and you squished an ant, then this number would drop by 1, and we would have 999999999999999 down the line. Right? The presence of the decimal point tells you if those zeros are part of the measurement or if they're there to show you the scale of the number. And with that, I'm going to stop us here, and I'm going to say everybody go over to our Google Classroom so that we can do any extra practice, go over any extra problems, and take attendance. I'll see you there.